Okay, now we want to construct the graph of y equals f of x equals 0.2 times the quantity x minus 3 quantity squared plus 4. Now that's actually fairly straightforward. We've done it, but let me explain the picture. First we start with the y equals x squared graph. Okay, well, here's a graph we've constructed of y equals x squared in white. Okay, then when we replace x by x minus 3, we have to translate 3 units to the right. The reason for that again is that to get the same value from x minus 3 squared, the value of x has to be 3 bigger than it would be if you were just doing x squared, which makes the graph move to the right. You get the same values, the same y values, but x has to be 3 units bigger. Okay, so we translate plus 3 in the x direction. Now that means we take every point of this graph and move it 3 units to the right. So I see this, the yellow arrow goes from here to here. We move the vertex 3 units to the right. We've moved the point 1, 1 3 units to the right. We've moved the point 2, 4 3 units to the right. And every other point of the graph. I can't draw yellow arrows for every possible point, but every point of this graph is going to move 3 units to the right, so the whole graph is just going to shift 3 units to the right, and our graph is now going to look very much like this yellow graph here. And when we do that, what we have is the graph of x minus 3 quantity squared. Okay, then we vertically stretch the graph by factor 0.2. Now what this means is we multiply every y value by 0.2, which means we make every y value 1/5 as great as it was. So here's our graph of x minus 3 quantity squared, our graph of y equals x squared shifted 3 units to the right, and now we have to take every point on this graph and move it 5 times closer to the x-axis, because the distance of a point from the x-axis is its y value, and the y values are all going to be multiplied by 0.2, meaning that they're all going to be shrunk down by a factor of 5. So, for example, this point, the y value is here on the yellow graph. We're going to shrink that down to here and get a point on this orange graph. Okay, here's another point on the yellow graph. 1/5 that value gives us a value down here. So every point on the yellow graph gets 5 times closer to the x-axis, giving us this very flattened out portion of a parabola. Okay, that is going to give us the graph of 0.2 times x minus 3 quantity squared. So we don't have a lot of room to write this, but I'm going to just kind of 0.2 times x minus 3 quantity squared. Okay, then we have this plus 4. What does that do? Well, to the function 0.2 times x minus 3 quantity squared, which corresponds to this orange graph, it's going to add 4 to every y value. So every point of this graph is raised 4 units. And that gives us the purple graph, and now that's the graph of our function. And I've extended with dotted lines. It's going to be parabolic. It's going to eventually rise quite rapidly, but it takes it a while to start doing that. And that's because the graph is much flatter than the original graph of y equals x squared, because of this step where we took every y value and decreased it by a factor of 5, or multiplied it by a factor of 0.2, which would be the same thing. Now I've indicated some brief statements here. The reason that we've got to move 3 units to the right to get from x squared to quantity x minus 3 squared is that your x value has got to be 3 units greater to give you the same y value, as I mentioned. And here we vertically stretch by factor 0.2. Y is multiplied by 0.2, so the point is going to end up 0.2 times as far from the x-axis. translate plus 4 units in the x direction or the y direction. That's a vertical shift. Adding 4 increases your y values by 4. And increasing your y values by 4 raises your graph 4 units. Now this function is in the form a times the quantity x minus h squared plus k. And any graph in that form can be constructed from the y equals x squared graph using steps very much like these. We translate h units in the x direction. We translate, we vertically stretch the function by factor a. We multiply all our y values by factor a, which moves them a times further from the x-axis. And if a happens to be negative, flips them over on the other side. And then we add k. That's our vertical shift, our translation of corresponding, in this example, the translation of plus 4 in the y direction. Multiplication by a corresponds to multiplication by the 0.2, where we flatten the graph. Okay, so this process is the same process you would use anytime you had a function in this form. Now we're looking at quadratic functions. We're going to look at some functions that have to be put into this form. For example, y equals x squared plus 5x plus 9.